Let's consider a business use case. We have a backend ServiceNow database which contains all the incidents pertaining to our organization. We have a chat application called Streamlit, and so that we can ask the questions, it will pass the question to the large language model. Large language model will hand it over to the agent. Agent will convert this natural language into the form of SQL queries. Then it will review the query. Then it will execute it into the ServiceNow database, retrieve the response. Further, it will review the response. If there's any modification is needed, it will modify it and execute it again. Then it will get the final response and it will provide us the output. Looks nice, right? Also, the Streamlit will support the Panda data frame, and also that we can convert this response in the form of Panda's data frame, so that it will show in the form of tabularized form, or if you want a graph, you can use it matplotlib or etc. Let's explore such application, right? Let's move on to the video. This is Melvin Satishan, and let's develop each and every component separately and assemble it together to build the final product. Thank you. In our previous video, we have already discussed about LangChain, MySQL and agent combination. You can refer that video if you have any doubt. However, we will take a 10,000 feet overview here. We imported the necessary modules, then we have imported the mapped the global variables. We created a large language model, then we created a database, and the large language model and database together we formed a SQL chain. Perfect. And in this query validator, whatever the query that agent would be getting created, it will validate the query with the question. So the query will be the context and the question will be as it is. We are passing it using the runnable pass-through module. Here is our special function which comes with a chain decorator. In this case, we have already created a SQL chain. In this SQL chain, we are passing the question, so it will get an SQL query. Then we have the another variable is our input. So together we will be passing it into get a correct SQL query function. So it will provide some instructions that to the question, and the question and context together will be passing to the query validator, so that it will validate the received SQL database query is correct or not. We will get exact SQL queries, and it will remove the additional quotations or any other alphanumeric codes in it. Perfect. Once we have done that, we have another function called dbQuery. It basically contains our chaining block and chaining execution. In that chaining block, first we are calling the SQL chain. This SQL chain requires only our input. So this SQL chain will provide us to output. One is our context. The context is basically the SQL query. So that SQL query will be passing here. Also, we have defined the question, right? That question will be passing through a runnable pass-through, so that the question input remains as it is till end of this workflow. Once we have received the context and the context, that context and question will be passing it to get correct SQL query. Remember that I haven't mentioned here the question, right? The question is coming from this SQL chain function, and here we have the question is runnable pass-through, so that this input, whatever the input is receiving in this end, will be passing across all the chains. Perfect. So this get SQL correct SQL query will provide us the proper SQL response. That SQL response, we are passing it into the database, and we will be getting executed. In this case, if you look at it, this is an additional block we have added here exclusively for our chat application. In this, we created a MySQL database connection, and we have assembled the final response as the database query. And using the pandas, we are doing a read SQL function, so that it will be passing the query to the database and getting the response in the form of a Python data frame. That particular Python data frame will be passing it into our Streamlit chat interface. So just to conclude here, we are getting the final response in the form of data frame, and that response is going to be sending it back or returning it into the database query. Now, Let's copy the whole code to a Python function file so that we can make it as a module. Here is our module. In this we have various Python functions, and especially we will be considering this database query that will take care of the rest of the functions. Now this db query is here, kindly note this point, and we have sql query.py file. Let's move on to the chat interface application. So this is also, we have done an exclusive video in our previous lecture, and the codes and everything remains as it is, no change at all. And additionally we have added some service role, and because we are going to develop a multi-agent chatbot, so for future enhancement I have already defined that condition here. Let's leave as it is for now. And additionally, in our previous video we were saving the chat history into a local database file, but in our case we have created a database, a dsn here, and so that it is going to save the session or the chat records to our external database, which is hosted in our docker container. Perfect. So rest of the things will be as it is, no changes until our response part. In this case you are asking a question, that question will go to chat with LLM function. This is a chat with LLM function, this is runnable with history. So here is our runnable with the history. We are not using that large language model anymore, because whatever the input question, that input question we are passing it into our database query, and with the prompt contains our question. That question will be passing to this function, and it will be getting the panda data frame. That data frame is basically assigned to a response variable. That response variable we are passing it into st.dataframe methods in the Streamlit. Perfect. So it would be listing out over there. Once that part is completed, we are appending that data to our chat history so that it will go and save in our database. That much only happening in our response table. Perfect. So let's do an execution. Streamlit run. Here SQL bot.py. We have a chatbot opened. Here we have multi-agent chatbot. Later we will add more services so that the respective agent will be getting selected from here itself. That will make sure that our chat is going to the right agent. There will not be any human error. So show me the list of incidents. I'm just asking the question. It has been printed all the incidents. Here I will say show me the list of low priority incidents uh, pertained to the network category. I'm just asking this question. Let's see how it behaves. It shows show me the list incidents in network. Let me ask in this way, show me the list of incidents in network. It is able to provide us the list. Now show me the list of incidents in network, and I will say list of low priority. Show me the list of low priority incident in network. Look at it, we have total 338 incidents in the network. Kindly note that our LLM requires a plain and simple English. If we use fancy wordings, it will be getting hallucinated. Okay, that is what we witnessed just a couple of minutes back, right? Remember that I made a typo here as well. Let's see how the chatbot is handling this situation. Excellent, it is able to provide us the response. And remember, if you want, you can download the incident like this way, and I'm able to open it in the form of CSV. Excellent. Okay, so that's it. Basically, I would like to let you know in this series. See, here is our incidents. Okay, and we will explore more in the upcoming video. And thank you so much for your time, and wishing you a great rest of the day. This is Melvin Satishan signing off here. Thank you.